Welcome everyone. Today we are discussing about the three variable K-map. In the last video, the previous video, we have already discussed two variable K-map as well as the basic of K-map. So we are discussing the three variable K-map, that is n equal to 3. Then you should have 8 cells inside the K-map. That means the value of n is 3. So you should have 2 raised to n cells, 2 raised to n cells or 8 cells. When you were using two variable K-map, then you should have 4 cells, and if you are using a 4 variable K-map, obviously you need 16 cells. Okay, this is how it works. Okay. This is how a K-map, a 3 variable K-map works. So we have min term m0, m1, m2, m3, m4, m5, m6 and m7. Okay, let's explain in detail. We have three variables x, y and z. If you have if the x have the value 0, then we will denote it as x bar, else we will denote it as x. Like if y have value 0, then we will denote it as y bar, and z have the value 0, then we will denote it as z bar. Okay. As you expect, the value should be 0 0 0 1 1 0 and 1 1, but there is a change, right? So I am going to explain how it comes. The first rule is any two adjacent squares in the K map differ by only one bit. So when you look here, the 0 0 becomes 0 1. This bit change to 1. Okay, and if you put 1 0 here, the 0 will have to change to 1. This 0 have to change 1, and the 1 have to change to 0. This is how 1 0 we get, right? So there should be two changes, and we cannot stick with this rule. So we avoid this by we are putting a 1 1 here, so that this 0 have to change to 1 and this one does not have any change, so it refers only one bit. In the next case, this 1 changes to 0, then you have only one bit change and you get 1 0. That's why we get m0, m1, m2, m3, m4, m5, m6 and m7. And you should learn how this writes. Okay, so in this column, in this row, you should have x bar on first. So x bar, x bar, x bar and x bar. Okay. Second, look at the y, the value of y and z. The y and z are 0 0, so y bar, z bar. Here 0 and 1, that means y bar z. Okay, y bar z. Here 1 1, value of y and z are 1 1, so just simply y z. The last cell, the value of y and z are 1 0, so we will denote it as y z bar. So x bar, y z bar. The next row, the value of x is 1, so in this row the value of x is always x. Here the value of y and z are 0 0, so y bar z bar. The next cell you will get 0 1, so y bar z, and next cell you will get 1 1, so y z, so x y z. And the last cell, the value of y and z are 1 and 0, so y z bar, x y z bar. Okay. Okay, let's take an example. Simplify the Boolean expression f of x y z sigma 2 3 4 5. This sigma means these are min terms, or you can write it as m2 plus m3 plus m4 plus m5. This is similar to this. Okay, both are similar. Okay. You have two steps. The first step is to put 1 for each min term. First is m2, then m3, then M4, then M5. Okay, so I put one here, M3, M2, M4 and M5. And the second is find adjacent cells and group it like 2, 4, 8, etc. So we have already put 1 for each min term, like M2 here, M4 here, M5 here, and sorry, M4 here, M5 here. Okay, now you have to find the adjacent cells and group it. You can have adjacent cells to vertically as well as horizontally, so you can group this here. By grouping this, you have to find the variables that does not have any change. So here you have x, and for both min terms the x is same, so say that's x. I put x because the value of the x is 1, and the value of y and z, the y remains y bar all the time, but the z changes from 0 to 1, so we avoid it. Okay, so from this we will get x y bar. Okay, and we are grouping this. From here there is no change in the x part of for these two min terms, so we will get x bar. Then we will look for y and z. The y stays still as 1, so we will say y. The z changes from 1 to 0, so there is no z, so x bar y. The answer is x y bar plus x bar y.